Yeah, welcome to our search meetup, Berlin Search Tech Talk number 7. Today we have 2 talks. So we have our guest, Doug Turnbull, and I'll give the other talk. And first of all, I want to thank our great hosts, HeyJobs, for hosting us today. Thank you. And I hand over to Shantanu to say a few words about HeyJobs.
Thank you. I won't take much time. Yeah. So welcome to HeyJobs, and I'm Shantanu. I'm machine learning engineering manager and managing mostly search and recommendation product at HeyJobs. So let's go. First, yeah, the agenda, we were supposed to start at 9, but it's okay. Just 15 minutes you can be there. We plan to close around 9:30 p.m. So just one announcement, it would be great if you could return all the bottles in the kitchen, everything waste. So we have less, we don't have to do much to close off. And yeah, first presentation we had from René, and then we have from Doug. So going forward, first, who have heard of HeyJobs before? Yeah, HeyJobs fellows, thank you. So I will just take 5 minutes to introduce what we do at HeyJobs here. So when we see that we cannot treat any more patients today, this is a normal feedback when you call a doctor and then they say that, oh no, we don't have appointment today, come after 3 months or something like that. Then there are sometimes problem with the schedule times of the train. Recently, when I was coming from my vacation to Munich, I had to wait 2 hours for my baggage claim because there were not many people to do that thing. So at HeyJobs, our main goal is to become the leading job platform empowering essential talent to help prevent the coming labor shortage disaster in Europe. So everyone know about this, like it's very much termed as we will be having a labor shortage in Europe, and this is our main goal to prevent that. And how do we prevent is that by help essential talent find the right job to live a fulfilling life. So when I say essential talent, it means train drivers, nurses, electrician, plumbers, basically everything what ChatGPT can't do, those are essential talents. So this is our main goal. Then going next. So about HeyJobs, we were founded in 2016. That is 7 years back. And then we have around 5,000 customers in Germany and Austria. And then last year itself, we enabled 35,000 hires for those customers. So, and we have 400 plus employees. So when it comes to labor shortage, there's always 2 sides to it. The first one is there's an employer who wants essential talent. And the second one is the essential talent wants to find a job. So for that, we have 2 products. One is Recruiter Portal. So just imagine that a medical store needs a pharmacist. So that person can simply come to a Recruiter Portal, add the job description he or she is looking for, and then add the budget. Based on that budget, we have machine learning models running. And what we do is like we distribute this job ad across different platforms like Facebook, eBay Kleinanzeigen, which is now called Kleinanzeigen, and different job portals. This is important because essential talent not necessarily have one app to search job for. They are mostly on Facebook, Instagram. So what we do is we try to find this passive searcher, job searcher, and the algorithm is mostly made to maximize the applications, which we can get it for the clients. So this is one part. And obviously the second part is if the talent wants to find a job, then we are also having a talent platform where the essential talent can come and search for a job. And this is the place where we also provide them to make talent profiles. Then we have this search over there, and also job recommendation. Since this is a search meetup, I will just quickly go into what we have, small thing in search. So in terms of stats, we have 1 million jobs on our talent platform. Then we have around 2 million search feeds per month and around 550K unique search session per month. But this last year, we just transitioned into from enterprise search solution to AWS OpenSearch and build infrastructure around that, build search, build auto suggest around that. And then we also, thanks to Doug for starting Quepid and René. So we also have Quepid. We use Quepid for relevancy testing, but then whenever it's about search, it's not about just relevancy, it's also business metrics. And for that, what we did was we built in-house a business evaluation tool, which measures, like, if we are supposed to increase the relevancy by 5%, how much that could impact the business metrics. So this is the trade-off which we can measure with this tool, which comes handy for product managers. And then we use Growthbook for A/B test. And yeah, that's it. So I pass it to René. Thank you.
Yeah, thank you. When Doug said he'd come to Berlin, I thought maybe we should set up a meetup and take to the public some things that we are chatting about, so we chat quite a lot. And so in this sense, I think both of our talks are a bit of thought process in the making. My talk will focus on offline evaluation, how we get from interpreting judgments to an idea how good our search system is, but at the core of this are our judgments. And I will focus on how to interpret them, how to collect them from a kind of a statistical perspective. So who am I? So I've worked at Search for approximately 16 years. My focus is on e-commerce search. I've worked with some of Germany's top 10 online retailers. I'm co-founder of MySys, Mixed Camp e-commerce search. So that's a one-day event that usually happens right after Berlin Buzzwords, quite interactive, quite peer-focused. I'm maintainer of Querqy, a library for query writing. And I'm co-initiator of the course project, which is like a template application for setting up an e-commerce search. All these are open source libraries. And I work as director e-commerce at OpenSource Connections. I guess some of you have heard of this company, some have attended HighStack, so organizing community events is one aspect of what we do. But usually our focus is on helping clients around the globe to get good search and related AI done. And that's mainly through consulting and implementation. And in this context, optimizing search and evaluation of search quality is at the core of what we do in many projects. So the problem that for which we want to find an answer is, how good is my search system? So maybe I want to optimize my search system so I get a new kind of incarnation of my search system, maybe an improved ranker. And how do I prove that? And how do I improve that quickly? That's the problem that I think is at the core of most search teams when it comes to quality. And there's a perspective on that that makes a distinction between online and offline evaluation. So online evaluation would be our A/B test, our multivariate test. So we've created a new setup of our search engine and then put it online and test it against the baseline. The problem with that is it's rather slow. Usually it takes like 2 weeks to get some kind of insight and some significance, and we might come with 1 million different configurations that we want to try out. So we can't do all of them online. The other part of that is the offline evaluation. So we have a kind of a proxy for our online KPIs that helps us find the most promising candidate. I think Doug will use a different perspective or introduce a different perspective on the best candidate. The way I want to understand best candidate here is using the candidate that gives us the best promise of beating the baseline by measuring offline using a proxy search metric. Yeah, so I apply a search metric offline on my million different configurations and then measure it and take the best candidates online. Part of this is an assumption that our offline search metric matches the KPIs that we want to measure online. That might not always be given, so it's worth trying that out. But that's not the focus of my talk. So let's say we have found our metric. I picked mainly one of them today, and we see, okay, it correlates with what we expect online. But then how do we get from evaluating a single hit, a single result for a given search query to an idea how good that entire search system is? I don't know where everyone is in this realm of search quality evaluation, so I want to make sure everyone's on the same page and introduce some basics. So in this case, I've tried to illustrate two search systems, so one on the left, one on the right, and I exemplify two rankers by two queries, three queries, sorry, query 1, 2, and then query n, so there could be more queries. And they bring back results so that they're ranked, and we have a kind of indicator how good a single result is, a single document is for a given query. So we have a tuple, a query, a document, and then something that's called judgment. And in this case, basically I've given it a 2, and there could also be a 3, and there could be many ways to come up with those judgments. Yeah, in this case, they were manually labeled, but there are other ways to do that. Once I've collected my judgments, I usually calculate a metric per query. So I'm not mentioning a specific metric here, but what usually goes into calculating such a metric is that judgment that I just mentioned. And some of the metrics have a model of the rank. Yeah, so we have this assumption that the first positions might be more valuable than the others, than the later positions. So in this case, I've basically taken all the grades, all the judgments that you see here, and divided by the position, and then summed them up. And a very, very simple approach. So search evaluation metric is one thing that we calculate per query usually. And then we calculate an aggregation of these metrics for our entire search system across all the queries that we sampled, and say, okay, we might use the average here, and say, okay, the system on the right-hand side did better than the system on the left-hand side. Yeah, I think that's what many search teams do to measure search quality offline. Who has done this? Quick show of hands. Yeah, I see a few hands. All right. Great. Core to this is this notion of a judgment and the question how we can find those judgments. And there are many, many ways around that, but this is not part of this talk. I'd be happy to talk about this. That's an area of my interest, but that would fill the week. But if you're interested, there are some pointers, or I want to share some pointers. Click model for web search, that's a reader. It's also available legally as a PDF. AI-powered search has a chapter on that, usually using a kind of Bayesian approach. That is to be a peer. So Doug is one of the co-authors, and I think that chapter is by Doug. I gave a talk on modeling implicit feedback at last year's Haystack US that uses a hierarchical Bayesian model for that. And then our company's training that we provide. We have a training on understanding and measuring search result quality. We also have an entire half-day dedicated to implicit judgments, judgment for tracking, another half-day, more or less, for explicit judgments. So it's a science on its own, but we take it as a given. And in my examples that I will use today, I will use manually labeled data on the scale that we just saw here. So once we know, however we know that, how we can come up with judgments, we have to somehow interpret. So how many of those judgments do we need is an important question. And then how do we interpret the results? So that's what I want to focus on. So the first question is, let's say we do manual rating, how many should we rate? So that's a tricky question, and that was asked to me by a colleague, Eric Pugh. And what I really like about Eric, he's a no-nonsense person. Just tell me how many. So that's Eric. And there's no, it depends, just tell me. And he had a need for that and approached it with a client. And while I was thinking, they had already rated all they wanted to rate. So I had a perfect data set after that was fully rated. And I can only give my answer with hindsight, and couldn't help Eric. But it really inspired me, and I did some research and some experiments that I want to share with this audience. So for my examples, I want to use a metric called discounted cumulative gain. Who knows what that is? Good question. Okay. So I want to make sure, again, everyone is on the same page. So what we do is we collect judgments, again, for queries and documents. And then, so we see this here for query 1, we have collected the judgments that we also saw on the previous screen. And then we apply a discount depending on the rank. And we see this on the in the formula on the right-hand side. So the variable I is our rank. So I've just copied Wikipedia here, should have been R for rank maybe. And then we have rel, which is our grade, our judgment. So this basically here expresses the discounted judgment for the ith rank. And what you see here is the discount, which is a function of the rank. So the further down we go the list, the higher, the greater the discount, and the lower the value of that document. So we see this here. For example, we have a grade 3 document at position 1. It's rated as a 7. And further down the list, a grade 3 document is only worth 2.49. So in the next step, we aggregate the weighted judgments, the discounted judgments per query. Now that's what many teams do. And then to express the quality of the entire system, they would just take the mean of these. So in this case, it's 1887. I think that is also what many of us do. And then in this context, oftentimes we hear about NDCG. So we put into a relation our actual DCGs on the left-hand side with the DCGs that we calculate on the ideal orders. So we put the best documents to the top, and then calculate the DCG for each of those. And then we would pairwise calculate this proportion, the actual DCG over the ideal DCG. And I've done this on the left-hand side, so that's the actual, so 17.52 divided by 1909 gives me this 0.92. And to many folks' surprise, I would say, if we look at, if we look at these figures here, so the DCG here looks a lot higher than the DCG does here, but the NDCGs are the same because we tend to neglect the IDCG. So this IDCG is a lot higher, so the bar is a lot higher to reach the optimum here. And basically, if you have a query that has a sort order of 100 versus a query where you have like a 223, the 100 would have a greater NDCG because it's already in ideal order. And that's somehow counterintuitive and confusing many teams. Nevertheless, NDCG is very popular, especially in academic research. All right, still back to the question, how many queries should we rate? And I want to share this setup with you. So that I did in hindsight. So I had 151 queries, 1,344 rated pairs, query document pairs, and they were all judged or rated as I lay out here. So 0 was definitely irrelevant, and 3 was definitely relevant. And if you look at the distribution of the DCGs queries, it's a bit messy. So it's not a known distribution, and it's really hard to work with this, it's problematic to start from here and say, oh, we need that many queries. So part of this is we don't know the shape of the distribution, but also we don't know our entire population. If you think in a statistical sense, the population size is unknown. We would have to consider all queries in the past, in the future, for this search system, and we can hardly make a statement about this. That's unpleasant, and we come back to this, but still at this point, even without applying any further statistical tricks, I could find something quite interesting. And that was about the order of queries for rating. So let's say we don't know how many queries we have to rate. We could still say maybe the order is important. When we stop, do we stop at a lucky point? We can influence this. And that's what I want to demo or show, indicate with these two diagrams. So on the left-hand side, we see the number of queries rated on the x-axis and the corresponding mean DCGs over those x queries on the y-axis. And the blue dots represent the queries in the order in that they were given to me. Yeah, and in the end, after rating all queries, so here I only rated 93, there's a reason for that, they basically got this NDCG that I indicate by the horizontal red line. And we can see that initially we were close to that DCG that we saw later, but then we have this little bump in the middle. But things could also go wrong. Yeah, so we could say maybe coincidentally we are rating them from bad to worse, from bad to good. Sorry. Yes, that's bad to worse indeed. So that's the green dots. Yeah, so we started with the worst DCGs and then got better and better. And if we stopped here, we would have quite a wrong picture of what we got. And the same the other way around. If we started with the good queries, the good DCGs, the queries that yield a good DCG, then we would have been over optimistic and then go down. Yeah, so order seems to be important. And on the right-hand side, we see the arrow. That's not terribly important. We can only deduct this from the left-hand side. So I was thinking, what if we looked at randomizing the order? Yeah, so look at, and what happens if I look at different orders or different orders of, let's say, X queries, and then evaluate where the DCG is. So to give you the data for that, so how is this to be interpreted? So what I did here is, let's say we look at this 20. That means we looked at 20 queries rated, and then we did this. We pulled 50 times 20 queries, yeah, and each time we calculated the DCG for that, and then created, got a statistics out of that. So we got a mean of those DCGs and standard deviation, and we could see two standard deviations to both sides here to give us some kind of confidence interval. And if you look at this, then it looks like our actual order was somehow artificial. Yeah, so it was very unlikely that our data would have created this shaping. Yeah, so basically, the learning from this is rate your queries in random order. Yeah, so if you don't know how many queries you have to rate, at least order them randomly if you have to stop at some point then you have not messed up your rating. And this sounds trivial, but what we see in practice is oftentimes, oh, we add to our test set the top N queries, and then we handpick queries, and then it's a test list more or less, so it stays in that order, and we rate them according to how we put them on the list. Yeah? And only once we've walked through this to the end, our rating, we will have we will have come to a more significant insight here. Yeah? So rate this randomly. And we want to keep the idea of sampling and randomness in mind. So I will come back to these techniques a bit later. So let's come back to our distribution of DCGs. So as I said, it looks horrible, but just to get an idea how many queries we should rate, I assumed a T distribution, so a generalized normal distribution, and start with 50 fully rated queries that allowed me to estimate a mean and the variance. And I did this for the DCG and for the IDCG. And what I tried to do is see how many samples would I need to see an effect that would get me half the way between my actual orders, my actual DCGs, and the ideal DCGs. So I wanted to go halfway in that gap between the two. How many, if I want to see that effect with the statistical power and a certain significance level, how many samples would I need? So for my test here, I would just need 5,000 queries, but rating 5,000 queries is a lot of pain. Yeah, so using the average number of documents per query here in this context, this would translate to 46,000 something query document pairs. So that would be a lot of work. Yeah, so that's hard to achieve just using manual rating. I want to move beyond using the DCG, or using the DCG the way we just saw it. And that would help us reduce the number of ratings that we need. So let's start again from what I explained earlier, so how teams usually work. So they calculate the DCG per query and then aggregate and take the mean. And there's an alternative approach by forgetting about the queries. We could just use the ratings or the discounted ratings at our set and look at their distribution. That sounds weird. Yeah? So we are so influenced by using queries and looking at query stores, and could still do this. But this gives us a lot of help here to reduce our effort. And I'm introducing the variable S. I ran out of good variables. Yeah? So I was thinking of J for judgment, but it's discounted judgment, and then we are close to D something. I didn't want this, and R would be relevance. So I just use S for scores. Yeah, so the score for me is one such item here. Yeah, so the discounted grade for a given query document pair at this position. So this feels uncomfortable. Yeah, so we don't have our queries any longer, and we don't see the DCG. But there is a way we can come back from this back to the same expression that or the same value that we have here. So if we use the mean of those scores, multiply it by their number, and then divide it by the number of queries, you would get the same. Yeah, so basically, because the DCG is nothing else than summing this up, and then dividing by the number of queries. Yeah, so it's two ways of getting to the same sum, so to say, or dividing the same sum. So if you want, you can come back from this. So that should express the same things, or at least go from one thing to the other, and could be used as a representative. So if we look at, assuming again a T distribution, which is not true, but just look at the number, just look at those scores instead of queries. So actually, and again, see how we can get from half the way between actual and ideal. So of course the means go down. Yeah, so our mean discounted grade for the actual is 2.18, and for ideal 29. And we can do the math for that, and we would need 21,817 scores. And that's basically the equivalent of the corresponding value to those query document pairs. So there's also query document pairs. And so we halve this. So why is that? So my explanation for this is that when we use the queries, we calculate the sums for the DCGs, we tend to lose some information, or have some redundant information in it that we don't need, that we have in those scores. All right, so that's a neat trick, I would say, and that allows us to look into things like, oh, how do we deal with missing judgments? Suddenly it becomes a different thing. But let's stay at this idea of creating a distribution first. So there's one technique, or there are many techniques to create a distribution. And one technique to estimate a mean of that distribution is sampling. Now, we don't know what the population of that distribution looks like, but what we could do is estimate the mean. And the way we would do that is we take a sample out of our scores many times and calculate the mean each time we take such a sample, and then take the mean of those. So these would again then follow into a normal distribution. So let's say we take, 100 samples. So 100 samples, do this 100,000 times, and then look at the means of those 100 samples. And those means have their own distribution. And this distribution is very likely to be the same distribution as our entire population. So that's a way to estimate the mean via sampling. And the nice property is that this can then shapes a normal distribution. And we can do this for several rankers and get then to normal distributions. It's much easier to compare normal distributions than unknown distributions. So I've tried that. Does it really form a normal distribution? Yes, it does. So for me, I could then find the parameters for this normal distribution, and that's a lot easier to serve with. So what does it give me? It gives me a mean of our scores, and we see we can get back from that mean to the DCG. And it gives me a confidence interval. So the famous two standard deviations, 95% of the values would fall into this. So I think that's much more meaningful, and that also helps us compare between search systems or between rankers. So I've done this for some setups here. So I've used 3 systems or 3 rankers. So the actual is the kind of, what is it, yellow, brownish one, the ideal and the worst. And now we have simple means of comparing these distributions. So in my case, I could not find a significant difference between my actual score distribution and my ideal. So that means they could come from the same system, so to say, from the same quality. I really like this a lot more, this perspective, than the NDCG. So this kind of replaces the NDCG. We can see the difference between the two. We can also formulate the distance or the difference between the two as a distribution between, again, be a normal distribution, and we can see how much it overlaps. And I think Doug will pick up on this in his talk and will probably say, you see, maybe NDCG is overrated. But we get more insights when we look at this as distributions. My next aspect here that I want to cover is how do we deal with missing judgments? So let's say for some reason we have rated some judgments for a query and others not. That might happen in case we see new documents coming in, or in case we changed the system so much, or we are not finished yet rating, right? So we might be in the middle of the process, and then somewhere in the middle, we might have missing values. So what do teams usually do in this case? And you see quite some tricks here, and I'm guilty of some of them. So I think a standard trick would be to replace the missing values with a constant value. Very often I see this being replaced by 0, and DCG has a bit of an issue with zeros, I would say, because it is not reflected in the DCG calculation. So if we just filled in a 0 and then calculated the sum over the column, the 0 wouldn't change anything. It would change something if we look at the score approach, because then that would be one more score that would go into the average. Another approach would be our just maximum judgment, or like a fixed value. Like if you use a rated ranking evaluator, that library, they provide you with a way to say, okay, my default judgment is 2. Yeah. Another approach would be you replace or you use the mean of the available judgments for the query. So to find the judgment for these two, would probably go to the ratings and then use the ratings that you already have for this query, and then use the average and replace it here. So the notion would be, oh, this is a difficult query. The judgments are all lower, so I use a bit of a lower value here, not a constant. There might be some sense to it, and there could also be an idea to use kind of or get some help for estimating it by using the positions, but that's all very arbitrary, I would say. And it gets us into even more trouble when we need this for NDCG calculation. So it's not easy to be solved. For us, it doesn't matter. So if we don't rely on the queries, we don't have to fill in anything. Yeah, so we can just use the available scores, and we have our distribution of them, and we would say that the remaining values probably come from the distribution that we know so far. Yeah, so would be a sample of that. I've tried this to show here. So I have my 1,400 or 1,344 scores, and as I progress in my rating, I calculate the mean score and then the standard deviations. And we see, of course, initially the data doesn't have much information, but as we continue, it seems to converge at some point, and at least we get a confidence interval at each step that we see. Yeah, so we don't really have to care. We have to fill in this query. Yeah, so we don't have to do this. We can just add scores into our system. And again, we should do this randomly. Yeah, so not per query, but just randomly fill in the gaps. There can be some indication that you might prefer one of these spots, but overall randomness works usually best. So let's come more to comparing search systems. So what I showed in the diagram, where I showed the normal distributions of the scores between search systems, basically what we can then do is calculate the difference between the two, standardize this as a normal distribution, and see how many, and apply null hypothesis, do the classical calculation here, the frequentist calculation. That's one way to compare the two, and very valid, I would say. There's another approach, and that seems to be in the experiments that I ran to be the most robust. So what I would do is, again, a sampling technique. So I draw a sample of, let's say, 100 here, and then a sample of 100 here, and say, okay, is B greater than A? And I do this numerous times and then get a probability. So if maybe I do this comparison, this sampling 1,000 times, and B was better 900 times, so I get a probability of 90% that B is better in that sense. So that's a very nice technique, and I found this to beat basically this approach, and also beat comparing the DCG measurement. Okay, and last but not least, I want to share one thing before I leave you with this. And I see a mistake on the slide, should be system A and system B, not 2 times system A. So let's say we still compare 2 search systems, and you might know the notion of active learning. So you gather more judgments to tell your system better, or to guide your learning by those samples. And I said earlier that randomization usually works best when we collect judgments. But when we look at comparing 2 systems, we can look at how the positions of certain documents change. Yeah, so basically, I've indicated 3 pairs. Let's start document with document 1, document 2, and then document 5 and 6. So they have flipped their positions each time. And we can say a change between position 4 and 5 might not have such an impact as a change between positions 1 and 2. So we should rather get the judgment for this one and do this later. And the same applies to the kind of yellow example, so document 3 and 4. So how do we find the document that we should rate? So we would find the maximum change in those discounts. So the bigger that change is, the more impact that will have on our statistics, and we should rate that early. All right. Yeah, to conclude and give a bit of a summary, we struggle usually to collect enough manual ratings to show significant change. So there's no way around that. And so we have to have kind of robust processes to assure we are not entirely off when we while we collect judgments, and if you have to stop prematurely, so to say. Working with distributions instead of metrics means helps us understand how confident we can be about our metrics. So instead of using an NDCG as it is, we want to look at a distribution. Sampling gives us a nice way to come up with distributions, and we can estimate our distribution parameters like the mean based on that, and then compare our search systems as a comparison between distributions. And this already becomes quite robust just in the case of we have just few results. I think the very important step here was that we resolved this dependency on queries. So going to those scores and neglect the queries gave us a bit of an advantage. So we need fewer samples, and it gets robust and converges a bit earlier because we neglect the notion of queries. Yeah, so the queries per se are nothing but a subset, nothing as a sample, and we constrain ourselves artificially to those samples if we group by query first. And then last but not least, random order when collecting ratings is key. So that applies to the queries, but also to the individual query document pairs. So this is not just a statistical thing, it's also to do with rater fatigue and position bias for rating and so on. So randomization in rating is super important. All right. Yeah, thank you very much. And I just want to highlight our training again. We have not scheduled one. If you're interested, let me know. It doesn't mean you're subscribing to it, but we should know somehow, is there a need for that? And things like that, maybe not as deep into statistics that I did today, part of the training. It depends a bit on the audience each time. Okay, any questions? Anything you want to share?
I think the answer is no from what you said, but do you recommend? I'm sorry. Do you recommend filtering the queries? It sounded like you were saying no, just randomly sample and do all the ones that are randomly sampled. But is there such a thing as bad queries? Because it didn't sound like you talked about rating the queries themselves.
So I didn't say anything about techniques for gathering the queries for which you want to collect judgments, and it depends a bit on the purpose of what you want to do with the judgments or what you want to evaluate. So usually, if you want like a general purpose set, just to say, okay, I compare this system with the other, and I want to have a representative sample. Then you could do like something like a biased sampling. You would say the more frequent queries have a greater chance to make it into my set compared to the less frequent queries. But you could also have other interests. So you could say, maybe today I want to focus on single word queries, because they are the most general queries that I have. And I know users go to browsing after searching, so there might be something wrong. So I collect a number of single word queries, and then you could do the same representativeness. Say, bias sample, most frequent single word queries, make it to my set first. And there could be other things, long tail queries, whatever.
Yes, are there queries that just don't make sense, and do you throw them away? Like if somebody asks, it's a typo, not a typo, but somebody submitted a query that was clearly not even a query, or is it interpretable?
Yes, that's a good point. As much as we depend on statistics and representativeness, eyeballing definitely makes sense. Yeah, and you get all types of things in the query logs, up to political messages or whatever. I've seen that, it makes sense to do that. So you first take your sample, remove from the sample what does not make sense, and then you might maybe fill this up using the same bias sampling technique.
Maybe a silly question, but have you looked at other metrics than DCG? Or?
Yes. So I think if you look at precision, binary metric, there's a paper that shows that average position, or that proves that average position follows a normal distribution. So they're on better shoes. I couldn't prove it, so that's why I went to sampling. I've tried hard, but I couldn't prove it. What else? Okay, I think we have these two groups. So graded judgment normally falls into this gain type of metric. And ERR would be a special case. I have not thought about this. But then you have the binary ones, and that's mainly average precision. I can probably throw this ball.
Hello.
I don't think it.
Oh, okay. So I can use just this.
There's a paper also that proposes to use permutations of two systems, and assuming under the null hypothesis that the difference will be 0, then they calculate the difference between two systems, and then this difference follows a normal distribution, and then they use like big Fisher's randomization pass. So how would that be different? Like,
So I'm not aware of the paper, but what you described sounds quite what I tried to show here. So it's not a pairwise thing, but what I tried to show here. And so once we have this distribution of the mean for each of the systems, basically the difference between the two is a simple normal distribution again that takes the difference of their means and the the sum of their variances. And then you can transform this into a standard normal distribution and compare it to the null hypothesis. So how many, after this transformation, how many standard deviations is our mean off? And that gives you basically that null hypothesis test. That will be a t-test, I think. Z-test, right?
Yeah, thanks. It looks similar. I think difference there, they also do like random permutations of the search results, and then you can do as many as you want up to the combinatorial limit, and then you can generate more samples for your test.
Please post the link to this paper into the Meetup group. It sounds interesting. I'm not aware of this technique, but it sounds interesting.
So we throw away kind of the query information. And while constructing this, did you think of examples where it's kind of degenerate? Maybe like you have sparse relevance at all. And then you would consistently get a better average per family. But if you look at actual, I don't know, I thought like, yeah, sure. Okay. Imagine we would come up with a data set that doesn't, maybe there's a lot of zeros. And one system kind of is better at getting any score for something that's relevant, but the other system is a lot of better for the ones that are highly relevant. And if you compare them on average, one system will be very often zero and will perform worse in this test, but might be very good at finding very relevant queries in sparse case. Like, it's a bit a toy example to come up with a case where this might not work.
I have to think about it. I'm not that fast, but I think still the treatment of zeros would be better here than in standard DCG because the zeros show up at all, and I give it a bit of a degrading. I would have to think about the semantics. So what would it mean if you have such a system, and what is the desired one? I think that also plays a role. Yeah.
Yeah, like in the toy example, it's kind of artificial. I'm not sure.
But I like the idea. That's an interesting consideration. Yeah. I don't know. I have to think about it. All right. Any further questions? All right. So then I think according to our plan, we'll have a 15 minutes break and then come back for Doug's talk. Thank you. Okay, so let's welcome our next speaker, our second speaker, Doug Turnbull. I think Doug is mostly known in the context of relevance search or search relevance. He's co-author of the book Relevance Search, the book AI-powered search. He started Quepid, the learning Turing plugin for Elasticsearch. That's what Splainer probably, and so on and so on. HeyStack conference. So please welcome Doug Turnbull.
Thank you, thank you. So my son is here, so everyone say hi, Ian. Yeah, let's embarrass him. And then he's my social media manager, and he's also in charge of my marketing, so he does my slides. And this is my intro slide that he made. I let him do this one thing. So he has no idea what I do for work, so he just made this slide. He thinks that's good. Finding Amelia Earhart. So I'm Doug the dummy. And just two quick things by means of, I don't know, introduction or talking about meetups. I think it's really powerful when people give talks. And one thing I like to think about is, because I wouldn't be in this field if I wasn't constantly embarrassing myself or like finding new ways to fail and learn. So I like to think of myself as a search enthusiast, not an expert. And the great thing about being an enthusiast is it requires you to constantly learn, constantly try new things, and anyone can do it. So if you're curious about something, getting started, you can be an enthusiast. And the best talks at meetups are from enthusiasts. So if you've never given a talk and you're really just learning and you're enthusiastic, those are fantastic talks. And I want to say too, someone actually I was just talking to was just saying that oh, people get these meetups, they give these talks on these really fancy things, and nobody talks about, but in real life, people use, they still have to do the basic things. So if you feel like you're just getting started and you're not quite to large language model fine-tuning crazy stuff, and you're just doing basic things, those are amazing talks, because there's a lot, in some ways, those are better talks for most people because they're more accessible and things that are what everyone is trying to apply to their work. So just to encourage you to be an enthusiast and give your son permission to edit your slides. I'm going to talk about this NDCG and PALs, really. René talked about NDCG quite a bit. And I'm going to talk, this is based on a blog article I wrote called NDCG is Overrated. And really, these are informed by some of my, both at Shopify and Reddit, and before that, so previously I worked at Shopify, now I work at Reddit, and all kinds of experiences implementing offline experiments and trying to make sense of them and get them to an A/B test, and deciding whether I need to give up chasing, the perfect metric and just ship the A/B tests, because quite often, to be honest, there's A/B testing bandwidth that we don't want to go to waste. That's always also a risk. So I want to talk about problems I've had with NDCG, and the sort of, not just NDCG, but the whole regime of judgment-based evaluation. And I say this all with love because, I help to create tools like Quepid. I'm written a lot about judgments and these things, and I think a lot about them all the time. But sometimes I just throw my hands up and give up because it's not worth it for evaluating many different kinds of things with search. And this is the general outline, and we're going to talk a little bit about maybe a different way of thinking about offline experimentation. So, and I won't repeat many of the many of these definitions. This is just a different way of getting what René said and many more slides. So this is we're just going through, DCG is one thing, and of course, NDCG is just DCG relative to an ideal. And in just that, you might think of some problems. Obviously, one common problem with NDCG is that I've often seen systems with NDCGs of 1 that are terrible. And obviously, this will happen when there's an ideal DCG that's horrible. Like if we have no spicy tacos in our search results, and this is the best we've got, then we could say our algorithm is performing as well as it possibly could. Success, let's ship this to an A/B test. And that's pretty common. So, okay, it's not that uncommon to stick to DCG. And this seems lower than we might suspect. If we compare it to another query, it seems to be an underperforming query. We saw that sort of lumpy distribution that René showed. Obviously, this is maybe sort of a gut check of this is not performing that well. There's also the issue of grade quality. Like we think somehow a miracle occurs on the left and we get this data. And of course, it's much more complicated than this. Like to get good labeled data of what is relevant and what is relevant for whom. There are many different definitions of relevance. There's many different intentions behind these queries that you have to think about, these things. And this is kind of an obvious one because some of these things are obviously not tacos, but maybe not. Maybe you're searching for a taco and you see a picture of a cheeseburger and you get hungry for a cheeseburger. You forget that they exist, or you decide you want popcorn and a beer, who knows? There are many different ways of defining what relevance really means. We'll focus a bit on engagement base because there are sort of like 2 ways of doing this. We should go out and hire a bunch of labelers and get them in here to tell us whether something is relevant or not, or on some scale. But then quite often we have some way of taking clicks, impressions, conversions, hovers, all kinds of interactions with the search UI, all the way to checkout, and try to model it to have a sense for when a user types in a query, we get some sense, maybe a grade from 0 to 1 of whether or not something is relevant. And it's might not come as a surprise if you think about this for just a little bit, where that this is just full of all kinds of biases, right? Our search UIs in particular give us all kinds of biases. Where do the clicks go? This is in my town in the US, just typing this into Google. And I am the rater, but so all the assumptions of relevance apply to me. So where do the clicks go? Well, first of all, we have this notion of position bias. And we have, obviously, as people scan down, you might have different rank positions on the page that give us just different notions of people even noticing it. And then you get, this is often seen as a linear top to bottom thing, but then you get weird seams in the page and things like this that sort of draw people's eyes. And you notice just by no fault of its relevance, these things will get more eyeballs, and therefore they get more clicks. So that happens all the time. We're just like, this happens to show up higher or in a weird place. It just gets more attention and gets more clicks, not necessarily because Taco Bell has the best spicy tacos. But that, and you can see there, if you sort of use the rating as a guide, that might give us an indication of this. Attractiveness bias, like, and this is sometimes related to this concept of perceived relevance. So you may have heard of this idea of perceived relevance, which is different than actual relevance. So perceived relevance is, I look at the search UI and I say, oh, that seems relevant, I'm going to click on that. In the click model literature, that's often referred to as attractiveness. They distinguish between measuring attractiveness, which is, this seems attractive to me, versus satisfaction, like this satisfied my information need. And so attractiveness can also be seen as kind of a bias, right? If we think, if actual relevance is the thing we're going after, then maybe this attractiveness is kind of a bias, and this Taco Bell gets a lot of clicks just because it shows an actual taco, versus this Torchy's taco thing is some disassembled burrito, right? So people just click on that. So yeah, so you get that bias. Maybe people actually go to this link and they, Taco Bell is notorious in the US for having fairly digestible food. And you click on it and you have a tummy ache later. There's this notion too of sort of our sense of confidence in the data. So we have lots of views, 135 clicks, 32 conversions on this top row, 2 clicks out of 10 views on the second row. Now, just out of this data, if you just take a straight click-through rate, you'll have a lower click-through rate on Taco Bell or on a higher one on Torchy's. But you have so little data on Torchy's. And so much of our search data is just dominated by power law distributions that this is extremely common. So it happens all the time in my experience at doing this at all kinds of places at high scale, that you think you might have a good search result coming back, but it turns out you have some just really noisy data coming back that's stomping over something that you're really confident that you know roughly the quality of it. And then probably the big kahuna of them all is people just don't click on what they never see. So I know of this really good taco place near where I live called Brazos, and it is maybe on page 5. This algorithm could never learn that Brazos Tacos is good. We would have no label data for this. So, and remember, all of this stuff, this is the input to whatever we're going to use to come up with some number. Here we're just using click-through rate. Maybe it could be our judgment. There could be all kinds of things we could do. There's a whole model. There's a whole book on click models that René mentioned, click models for web search, that has many options depending on your how you want to think about your search problem. And yeah, but at the end, if something's not on a reasonable place that anyone's going to receive clicks for this, you're not going to receive the evaluation data directly. So that's a big problem. And I want to mention it's a particular problem with search that sometimes it occurs in different ways in like recommendations or things. But because search is such an intentional activity, you're really using a lot of active thinking, you're paying attention. You sometimes don't want to infer like related. You can experiment with this, but for evaluation, it's tricky. It's a bit trickier to think about like, oh, because there is some like query linked in session with this, that is somehow related to this thing. Like if you have spicy taco and then like spicy burrito, that gets a lot of clicks. It's such an intentional activity. Maybe Brazos Tacos actually has a fantastic burrito, but terrible tacos. It's really hard to make that conclusion. Whereas sometimes with more passive activities, the downside of you messing that up, like in a recommender system, isn't as catastrophic. Like people are very specific at what they want with search, which is why I don't know any search interface where someone doesn't think it's terrible. That is just the cross we bear. So with these biases, especially the presentation bias, we're already working on maybe improving the precision of this, top couple search results for this query. We're already at a disadvantage. It's a problem. N here is going to be very small, and we could just forget about the NDCG and just think about DCG even. Just anything that we want to evaluate using search results. We're working on a small set of results. And so when I'm really investing my time in a significant experiment that I want to ship to production, that is really going to revolutionize the face of search as we know it, it's almost certain that most of my queries are going to have a lot of unlabeled search results. So this is something that gets talked about a lot. Like when you change or increase recall or change the results that comes back, it naturally is this is just going to fall apart. Whereas if I'm making maybe tiny tweaks to the algorithm, I could see NDCG impacts, but at the same time, moving something from 2 to 1 or 3 to 1, is that really going to have a huge impact on an A/B test? Maybe, maybe not. Yeah, NDCG struggles with recall. So far so good. Maybe a bit of a bigger problem, and too bad Andreas isn't here unless I missed him. He did let me use these slides, and I do want to mention this other talk with Haystack 2019. I do wonder how human beings interact with search results is often not quite this idea of like there is this pure sense of a query document relationship or a number we can put on it. Things matter a lot in the context for which they're shown, right? And this is one of the most, I recommend this talk all the time to people who are getting into search. It's a Mises talk from 2019 from Andreas Wagner, measuring and optimizing findability in e-commerce. He shows this query bicycle. You obviously have one side that has bicycles. So in some sense of relevance, you can imagine that our algorithm has always shown what's on the left. Somehow we shuffle some related things to the top, and you get increasing much more higher clicks and GMV on that search page. So some people may have heard this concept of search result diversity. It's not just the actual relevance of the search results, it's how they compare to one another and how they are compare and contrast to each other. And I especially think in e-commerce, but in other contexts, even research, people don't necessarily want 10 relevant results. What they want is 10 results that give you contrasting points of view on that query to help them make a decision. And that's pretty, when I learned that and I thought about that, it's pretty eye-opening to how you think about search and relevance and whatever this is that we do, improving the quality of search results. So obviously it's much more than just like query document relevance. I will say in this talk, he does say that query document relevance matters, but it's much more than that. And then LexisNexis has a similar thing where they talk about different levels of analysis. The LexisNexis is the legal search engine, so this is research. And they talk about, they have a system where they evaluate things, just give me a number. If they give something to their raters, this is human raters actually, because they do legal search, it's very technical for that domain. They say, you know, which of these search results pages do you prefer? And they say in many cases, although what's on the right is useful for other reasons, in many cases they would just rather get a number on like, do you like this result listing or not? Is this sort of helping you solve your problem? And there are trade-offs here, right? There are pros and cons. So NDCG self is somewhat flawed, just sort of concluding the labels themselves will always have biases, and this pure view of query document label model of the world is flawed. It's a sort of like really basic sense of physics that, like, you know, when you drop an apple, things go down, but there are so many more complications to gravity. There are actually 3 body problems. There's sort of like 3 search result problems when you want to compare and contrast many different things. And I do want to mention that doesn't mean it's useless or even bad, but I think it needs to be understood and appreciated within the context that you have this data. There is this, I think sometimes, and this is true in search, but it's true in many things in business, everyone wants to have this one pure metric, but then the one pure metric just averages in so many other performance metrics that it becomes impossible to interpret. Whereas having a reasonable handful of metrics that's easier to understand and that you could ask reasonably, like, what does it actually mean, is more useful. So let's not get too beyond sort of like what let's make sure we appreciate it for what it is, but not get beyond that. And of course, if we want to do machine learning that optimizes ranking, there's a whole library of systems and everything that depend on us having, well, not necessarily good NDCG, but a good judgment system. So that's still very important for that. Yeah, there are many different ways we can measure things. So I want to talk about what I think we're missing in offline evaluation. And again, this comes from just having done a lot of experimentation from my own personal experience, and mostly drawing recently with Shopify and Reddit experience, sort of like what we're missing. And what I just want to ask the question, and many of us are in this situation, just starting from, why don't we just YOLO shift to A/B all the time? And honestly, I will say that sometimes teams get away with this, and it sort of depends on their level of are they using up all their A/B testing bandwidth? So if they're not already using their A/B testing bandwidth, it's not the end of the world. And what their goals are. So one maybe anti-pattern is if you make some, like, if you're like, I don't know, parameter searching or something, like trying to find that there's a title that's boosted by a factor of 10 there. Maybe you're like, oh, what is the best value for that? That's probably a not great situation. But yeah, why don't we do this? One reason we don't do it is we think the purpose of A/B testing is to make metrics go up. But I want us to think about, like, the purpose of an A/B test, it's to really like gain knowledge about what will make a metric go up. It's about knowledge and science. So when we just sort of like black box change something without really understanding a change, ship it to an A/B test, and then sort of graduate it out of that, we can do that, and we could do that to some extent, but we don't really gain much deep knowledge. It's sort of like a very basic sense of science. We're working at a very coarse grain of abstraction, as if we have this extremely basic view of, like, I don't know, wood burns, and if I don't know, just like, I need a better physics analogy. Like almost say you have this like very basic, not even Newtonian sense of physics, and you're not going to dig deeper into why things are happening the way they are. And there's a million questions that the PM in the situation might ask, like, can we do it again? Will it work in 2 weeks? Can we iterate it? And what was it that we actually shipped? And I really like this quote. I can't remember who said it. It was in a business book, but it was something like, you know, we're going to change our, it was a business thing, from change our perspective from winning, out, like beating the competition, to out learning the competition. I really like that. So one analogy is medical testing. So what would happen if we, in a medical testing context, we didn't really understand what we were building, and we just sort of like shipped it to clinical trials, right? Probably bad things would happen, like the downside risks of this are pretty terrible. But just from a purely scientific perspective, we wouldn't really understand how to go back to the factory and tell them to keep making that compound. And we often skip this step on the left. So yeah, we don't want to have some random mix of chemicals like in his lab, or random learning drink model in Doug's notebook, because we're not really sure what that is. So our actual job is to really develop and test hypotheses. So we want to ship some right compound to production. We want to like understand the sort of shape and nature of what we ship to production. And then we want to have some business metric come out. And one way of understanding the sort of like nature of what we ship to production and what it is and what it does, how we could describe it, is maybe with NDCG, but I'm going to discuss that there's maybe other ways of talking about that instead. So it's sort of like, instead of this, is this a good change? We want to ask the question of, is this the expected treatment? So we often, the other anti-pattern that I've seen is we get so obsessed with offline metrics, and we spend a lot of time on this, that we actually miss A/B testing windows, because we're like trying to perfect the stuff on the left instead of trying to get things to an A/B test quicker. So what I want to get at is something that kind of gets at both of those. So when I think about this, I think about sort of like, what am I trying to get into production? Am I getting the expected treatment into production? And really is helping to develop, what I've tried to do is develop a meaningful hypothesis. So do I change the queries I would expect from this change? How much should I change them? And so that's purely a delta, not even like good or bad change. And functionally, is this the change I intended? And functionally, this could be as simple as like literal unit testing, to a different kind of measurement scheme that's sort of like getting at the specific purpose of this exact experiment. This is sort of like, it turns out that what I'm describing is actually has a name, and it's something that I don't think machine learning really talks about enough. And it's this concept of treatment fidelity. So treatment fidelity is basically, we have a scientist, they have a new medical procedure, and then a bunch of doctors don't actually apply it correctly, right? Someone put the shot in the left arm, not the right arm. I waited 3 weeks instead of 2 or whatever. I told the patient to fast before the shot, because that, in my experience, seems to be the right thing. This is something that happens all the time in medical research, like doctors apply their intuition that screws up our ability to interpret the results. And then we say, we can't trust this, right? So scientists will go through and they'll say, like, they'll update their protocols, they'll go through practice runs, they'll check compliance, and they'll measure whether or not there's fidelity. And then if it's not actually doing what they expect, they'll actually go update their protocols and try to get things closer to their level of expectation. And search and other ML systems, is this system actually doing what I think it should be doing when I put it into an A/B test, is sort of a question we don't ask enough. So maybe as a naive example, it's often thought that like title caret 10 will mean a match in a title score is always 10 times a match in a body score. There are all kinds of confounding factors actually that mean that's not always true. Like document frequency is part of the score calculation, and title and body might have different document frequency for a given term match. So right there, our mental model is sort of like measuring one thing, but it turns out we're measuring something different. We're impacting the wrong queries, like I said. We think it should only impact these things that have strong title matches maybe, but it turns out that other things are impacted. Other system concerns, like, obviously, like why is the predictions being cached for so long when you did off, you had a different expectation that things would be more live. Like, why is there not daily retraining of the model when we expect there to be, when in reality, our system resources, we can only do like weekly or something like that. So I'm going to talk about a bit, I'm going to talk a bit about like what I mean by treatment fidelity and offline search relevance. So I've already talked about a little bit about test. Test. I am the very model of a modern.
No idea. The box also good.
No, the box is acting as a microphone for the record.
I just turned off now again.
Yeah, maybe.
Test. Wow. We've used up all of them.
You have to speak a bit louder, but we make sure we record it. Yeah.
It's my emotional support. Test. Speak up.
Yes.
Okay. So I'm going to talk about one approach I've taken to offline evaluation that's a bit more practical. I'm just going to hug this because it feels better. Did I change the expected queries? How much is that change? And functionally, is that the change I expected? So one way of quantifying change, there's several statistics that you could use. Rank biased overlap is probably the one I've seen the most. And really, this is asking the question, how much did the results change? And this will give me a sense of the possible impact, good or bad, that something could have in an A/B test. And Shakar's similarity is what we used at Shopify for this. Actually, we just would say, like, how similar are the results before and after? And if it was hugely different and every query was changed, we knew we were taking a risky bet, but maybe it was worth it if we really believed in the change. Yeah. So, like, did I just, maybe I have this spicy taco treatment. Did I just target food queries? Oh, higher is by less change. It turns out puppies and Tiger King also change. That's not good. So we tweak a little bit and we iterate our algorithm and we look at our query population and we only impact the queries we expect, right? So that's one way. Is this a change I expected? So often, this is an interesting one because I think this is where things can get pretty interesting. You often design a relevance algorithm to sort of like treat a specific part of the problem. Obviously, there's judgments, like judgments just tell us whether NDCG went up or down. But what if there's a specific part of the relevance problem that we think is important for us to target? And we say that I expect something like, this is maybe a sense of like whether the query being classified to some taxonomy we have, like a hinge food, is also related to what's in the like stuff down there. So, and we could invent a metric that sort of measures this, right? We could invent a measure to say, like, is the queries taxonomy that we've discovered somehow similar? How similar is it to the actual things that are in the search results. So we might come up with something like 0.7 for this. So this is just a dumb, don't worry about the math here. It's just a dumb metric that I made up. So sort of like sum whether or not we are some semblance of proximity to the taxonomical similarity of our query. So we're not making a statement whether or not this is good or bad. Our hypothesis is that this is a good thing. And we might say, oh, we've increased the similarity between the query and the documents, some factor, and we haven't done it in these other cases. So we're actually implementing the change we expected over our query population. And there are many different things that we could do. We could even do as simple as like, did we decrease the number of search results? This is a really simple one. Decrease the number of zeros search results. So if we have a set of queries, let's say 5% of our queries have no results. Otherwise, we like our relevance algorithm. We could simply devise an offline test that says, did we leave 95% of the, how much, not even did we, how much did we leave 95% of the queries alone? And how much did we reduce that 5% of zero results to actually have results? And we hypothesize that this will result in a positive A/B test, but we may learn that it doesn't for some reason. Maybe we have a research system where it's important for us to say when we don't know the answer. So really our offline priorities is really about, in my perspective, forming a reasonable hypothesis that we understand what we're actually producing in some measurable way. So really only expected queries change, expected query change implemented, and sort of a neutral emoji on is this a good change? Like, we wouldn't be doing this work if it was a bad change. And then finally we get to the A/B test is really when we care about like the result of the test that we're trying to do. So really it's about forming these well-formed hypotheses and then finally testing whether or not we have this sense of, our systems are achieving the sense of treatment fidelity that we've called out. So in conclusion, science is hard. I do think simulations are still valuable. And we have simulations, for example, in health testing. We have computer simulations of human bodies that we do before animal testing, which I don't know, not quite a simulation if you're a rat, but it's, you know, we do these things. Simulations sort of like iterate on quality a bit offline, not just fidelity, but really in my opinion, we often miss the fidelity part. We often are not entirely clear on what we're implementing. And often we try to use things like DCG to debug these things when really we just need to have our own way of testing the actual thing that we're trying to do. That is often one-off or specific to a narrow set of problems like diversity or reducing zero result rate or some sense of spell correction or something like these. These are often specific to a set of problems that we're actually trying to solve within search. But these simulations, there'll always be limited about them. And I think it's important to accept the limitations. And we won't gain real knowledge unless we actually are getting under the hood to measure and try to prove what we're building is what we intend to build. So, and credit to DALL-E for coming up with that. So the AI overlords, I'm giving you credit in the future. In the end, like all of these little things we're doing, whether or not we have some notion of decreasing zero result rate or maybe improving topical relevance through some taxonomical labeling similarity system or result diversity, these are all just models. We're sort of like building this connection of theoretical models of how the search world works. Each of them almost has their own like loss function of things that we're trying to optimize for in different ways and maybe interactions. And there could be query intent in here. That's often another sub-problem of search. And then we almost create these in the same way, you know, we might create like a nuclear reactor to prove some notion of physics. We have these models and theoretical frameworks that are sort of like the offline evaluation ways of thinking about the world. We need to build some thing that we need to introduce into the real world to actually prove whether or not these exist, like a probe or an actual experiment. So, and oh, by the way, Ian did this too. Thank you, Ian. Thank you.
Any questions to Doug? I tried to throw it. Yeah, cool. I was nervous for a bit. First of all, yeah, thank you for the talk and also for putting the idea of spicy tacos in my head. I'm hungry now. Thank you. What would you say are like good ways to form a hypothesis in terms of identifying queries that could be improved or what the improvement could be, because sometimes there's just a ton of data and it's hard to sift through it all.
Yeah, and Renee, you can feel free to answer this too. So yeah, this is a challenging problem. So a simple thing for us at in e-commerce, it's a bit easier because we would have a population of queries that would have a certain level of sales, and we have this other population that didn't seem to result in any sales. So that helped us sort of target like, oh, maybe these kinds of queries or zero result queries, these are just no opportunity for a sale. So how do we introduce something? It's a bit different in a context like Reddit because we're sort of like optimizing a bit differently. It's about a bit more like increasing daily average user or time on the site and like people having good interactions and that kind of thing. And it's a similar kind of thing. There's just a query population. The tricky thing is how you build different segments of queries. So how do you group them together in a way that you can form a meaningful hypothesis? So zero results are an easy one because we can say this is clearly a group that has zero results, but maybe there is actually a type of query that has zero results that performs poorly and another type of query that's similar to that you don't want to impact. And so for me in an offline world, I would say I want to introduce some results for these, but maybe not impact the ones negatively that are sort of, think of a concrete example like misspellings. Like maybe there's misspellings that actually perform well and actually sell well because we have some synonyms in our system. So I want to like target this group of misspellings, but not affect those. And finding that like grouping queries together in sort of a taxonomy of queries is, I think, a key skill for like a search PM. So.
Yeah, one thing to add is I think most of the time we focus on the data first and then go to some analysis, but we tend to neglect the UX perspective. Yeah, so qualitative UX research, I think, could add a layer to that because ultimately what we want to measure is this improvement for the user, and the data is just a proxy for that. Right. You want it again? No. Okay. Don't be afraid of this thing I go around. Yes. All right. Any further questions? No. Oh, there's one. Okay.
Test. I think it's not working.
You see the voice in the.
Okay. Sometimes, because our search is working in some UI, right, in some context, some business context, what do you think about sometimes UI changes are more powerful than any search changes you can make in your search engine? It's working perfectly with just a crappy UI and vice versa. Just a really good UI and you don't need to touch your search system actually. Yeah. How do you test what's working or what's not working in this kind of sense?
Yeah, that's a great question. And I think it's related in some ways different than this, because in one way it's related is really powerful search system. There's a really close connection between showing the user we understand their query and the UI. So there is this notion, I think it's related to some extent, of query intent. Like, do I understand your query intent, and am I reflecting it back to you with a UI that's specific to you, what your needs are? And so if you have a sense of, modeling query intent and a way of thinking about that offline and a theory of query intent that you can validate or not, that is one way, because you can sort of get the right UI. And then the second part of that, often I talked a little bit about perceived relevance. Also reflecting back the user their intent is like, how do you present those results in a way that really highlights that you understand, like a really simple thing, like from early days of search is just result highlighting, right? Can you actually show the snippets? René and I have worked on projects where people will come to us and say, the results are irrelevant, but the results are actually perfectly relevant. It's just, we have to find a way to highlight to you and almost like have a relevance of snippets within that to give you a sense of why this is relevant.
I think in the first place, if you look purely at the kind of search result quality evaluation, not at the UI stuff, the UI can become a bias. Yeah? So like the position, do I add a nudge? Yeah, only 5 left in stock, or do I put the checkout or the add to basket button also on the search result page, or only show it on the product detail page, maybe on an e-commerce search? So we can integrate that in our model. If you say we create a model for implicit feedback, we can consider that and integrate that. But ultimately, we want to exploit it, yeah, as you're saying. But we can deal with that, I would say. But you have to be notified or notice when changes happen, of course. Yeah. What are the 2 roles in American football? The guy who throws and the guy who catches, right? Okay.
So if you're using some kind of machine learning model to train this, you kind of need to optimize towards your loss function anyway, and then that loss function normally relates to NDCG in some way. So then you can would you ever kind of force a change even if the NDCG was not improving in that thing or your loss function, because you still kind of need your loss function to improve, and then you assume NDCG improves as well?
I would, and it would happen frequently, like at Shopify especially. I would say like there may be 25% of experiments we actually we cared about improving NDCG, and then there are other times we more or less use NDCG as something to check. Why is it going down, and how is it going down, and is there a way to understand this qualitatively? And then so we would open up like okay, yes, we know we hurt NDCG often because we increase recall or we change the set that comes back. But why, and is it something we can explain with the result we're doing? And that's okay, because really what I'm trying to do is get information and feedback on this. And then finally, the other thing I would say is I think René had a really good slide about active learning. And there's also some stuff in AI-powered search on active learning. Like when you do introduce a novel change, you can get feedback on that. And you may broaden your set of labels too for a ranking model change. So yeah, and NDCG, like all the reasons I said NDCG can be flawed too. It's just, there's often things we don't know if they're relevant or not. They come back, and we just have to go with, we're not necessarily putting something in an A/B test because we think it's always a good change, but often just because we want to learn if it's a good change.
Anything else? Any further question? That's great. Okay, so thank you all for coming. Thank you, Doug, for speaking. And yeah, round of applause. Thank you again, HeyJobs, for hosting us. It's a great venue.